telescope, and so on. So there are many different types of telescopes. So um, there are two main types of telescopes that we should be aware of, and they are called refractors and reflectors. So the refractors, basically they have a lens. So this is the typical telescope that whenever you think about a telescope, this is what we always think about. So basically you have a lens over here which is collecting all the light, and there is another lens over here which is called the eyepiece, which is used to project that collected light to the eyes. So you have a big lens which is called the objective lens, and then there is a small lens here which is called the eyepiece, which is used for forming the image. And then there is a second type of the telescopes, which is the reflector telescope. So in reflector telescope there are no lenses, we have mirrors. So we have a mirror over here which is a concave mirror. So any parallel light that is coming from distant stars, this will get concentrated at one point, but basically that one point will be inside the telescope, but yeah, you can't just peep into the telescope and see. So you will use another plane mirror to get this cone of light outside, and you will put your eyepiece here and try to see. So this is what a refractor would look like. So here you would have the aperture lens would be here, and then the eyepiece is over here. Similarly, in a reflector telescope, so the concave mirror that I talked about is over here, and then there is a plane mirror over here. So this concave mirror, it actually creates a cone of light which is coming over here, and this plane mirror just reflects that cone of light outside the telescope, where you can have an eyepiece and you can see through that telescope. But these telescopes, for me, they were really expensive. Like this particular telescope, the telescope itself, this just the tube itself costs about 50,000-60,000 rupees, and this mount costs more than 1 lakh. And this kind of telescope, also, if you want a good size telescope, it will cost more than 40,000 rupees. So then I thought, maybe why not try to make a telescope myself. So I started thinking about making a telescope and started studying how to do it. So a telescope has many different parts. So if you are planning to make a telescope, then you have to consider all these things. So there is there is a primary mirror which we talked about. So this aperture mirror, this is called the primary mirror, and this is called the secondary mirror, which is just a flat mirror. There is it's an ordinary sorry, it's not an ordinary, but it's a flat mirror. It's not curved in any way. So if you see here you can see this thing. This is the primary mirror, and here you see this is the secondary mirror. Can you guys see my mouse cursor? I think so. Okay. So this is the secondary mirror. Now we need a lot of mechanisms here. So one thing is, first thing is, how do you hold this primary mirror, right? So you have to support the primary mirror in some way, and that's called a mirror holder. And then so there is this metal thing that you see, which is marked as G. So this is the mirror cell. This holds the primary mirror, and we should have a way to adjust the primary mirror, because if you don't have any adjustments, the primary mirror may be oriented in some way which is not at all parallel to the tube of the telescope. So you need some way to do the adjustments, and all those are done using a mirror cell. And this mirror cell has to sit in a box, that is the mirror box, and we should have a way to move it. So you have all these different shapes which are useful for moving the telescope. And then here for the secondary mirror, you need something to hold the secondary mirror. That's called a spider. And then you need something to put your eyepiece. So you have a focuser. So you have to have all these different parts to make your own telescope. So first of all, this primary mirror, that is the most important thing, which is so which whose quality is very very important. And either you can buy this primary mirror or you can try to make this primary mirror. So there is this great guy named John Dobson, who actually started making his own mirror. And I mean, even before him, a lot of people were making mirrors, but he kind of um, advertised it to the common people, and he showed that even any common person can make his own telescope without the need of any lab or any heavy equipment. So just with basic materials that are easily available, we can make our own mirrors. And this is the guy who showed that. And this design of the telescope is called the Dobsonian design, which is named after John Dobson. And to make this kind of primary mirror, what you need is, what we do is we start with blank glass, which is just flat. Okay. And from this flat, we have to make it curvy. So here you can see this. So you can see that the mirror has this surface has become curvy. So we use some material called abrasives to just make that particular shape. And this is how you do it. You spend many hours just rubbing two plates of glass against each other. One of them will become convex, the other one will become concave. And we throw the convex part, we don't need it, and we use the concave part. And once it is so we do the grinding and polishing, we make the surface of that very smooth. And once that is done, you can get it coated with a layer of aluminum, with a thin layer of aluminum, and this will make it very reflective, and we can start using it in the telescope. So so I got some help from a local astronomy club, and I made such a mirror, and I made my own telescope, which looked like this. So it has a tribal design, but yeah, don't worry about the design. But this was a telescope that I made with my own hands, and it was very very exciting to do this. Although the quality was just okay, not the best quality, but I learned a lot of things making this telescope. The primary mirror, this primary mirror that I was talking about, so the diameter of that, which I made, was 200 mm. So you can just go to any glass shop and you can just get a 200 mm or 8-inch diameter glass plate, two of them, and just start making your own telescope. And the focal length of this was 1625 millimeter. So it's called F8 mirror. So F8 is because, like, if you multiply 200 into 8, you get 1600. So almost F8 mirror. And then so there was a secondary mirror here, and then the focuser was over here, where you could put your eyepiece and see through the telescope. So I had a few eyepieces. So with 10 mm eyepiece, I would get about 162x magnification, which is a pretty good magnification even to see the planets and galaxies. Instead of having this kind of mount, I made this kind of mount, which is called an equatorial mount. So this is easier to track the stars. We will come to that later. So basically, another idea was that it just has a metal pipe and three metal legs, and all of these were dismantleable. You could just remove the screws, put them all together in one bag and carry them. So the advantage of this telescope was that it had good magnification. I could see planets and galaxies, but this tube was very big to carry around. And also because this tube was a PVC pipe, so that you get for for irrigation. You have all these water pipes, and this is the same pipe. I just got one length of this pipe and cut whatever length was required for me, and I just used it. And also I used a plastic focuser. So if you put a big DSLR camera, which is about 700, 800 grams, the focuser would just bend. So there were some drawbacks, but it was a really nice experience. So with this, I could see many things. Like this photo was taken with that telescope. So you can see all these craters on the moon. And it was a very nice thing to see. So one thing I wanted to tell you here was that when I did this, I was really inexperienced, and um, I wanted to see the moon, and I thought, okay, when is the best time to see the moon? And I thought, okay, maybe when the moon is full and very big. So I went on a full moon day, looked at the moon. I couldn't see any craters. I was shocked. I mean, what is this? Is this some fault with my telescope, or what's going on? But then I realized that you see here, you see this part of the moon, you don't see many craters over here. I mean, there are craters over here, but they are not very prominent. But on this side, you can see many craters. And that's because the craters are are visible when there is a shadow. So you see this particular crater, there is this black shadow over here, and there is this light over here. So there is the sunlight is actually falling from this particular direction, and it is causing a shadow over here. So when we have this shadow and light, then we get good good view of the craters. But on a full moon day, it is like noon on the moon. So the sun will be on the head as seen from the moon. So there are no shadows created. So when there are no shadows, then you will not see any more craters. So if you see this part here, it's kind of noon for this part of the moon, and you don't see many craters. So good time to see the craters of the moon is when moon is kind of half moon or a crescent moon, when there is a when the light is falling at an angle, and you can see all the craters of the moon. Also, I was able to see many different planets. So Mercury and Venus. Mercury and Venus also look like a crescent shape. Do you have the picture of the full moon? Yes, I think I have the picture of the full moon. Let me check. Yeah, this is a picture of the full moon. So this is actually highly enhanced photo of the full moon, and it was not taken with that particular telescope. This was taken with a different telescope, which I bought later. So here you can see some colors on the moon, but usually you don't see all these colors on the moon, although these colors are pretty much real. In the sense that after I took this photo, I took it to Photoshop and increased the color saturation, increased the colors to reveal all these faint colors. These colors are not very prominent on the. And you can see here, I mean, it just looks like a ball. And although there are craters here, they are not very much visible. Okay. So does it make sense? I hope so. Was there another question? Sorry. I mean, you better unmute yourself and ask, because I may miss the chat. How satellite imaging works? Uh, how satellite imaging works. Satellites have the camera and they are looking towards the Earth. I don't know what. There is an audio issue. Voice is not clear. Voice is clear to me. No, it's clear. Okay. How to take a picture from telescope. Okay, I'll show you that. We need to capture during a clear sky, right? Cloudy clouds would deter the incoming light. Yes, that's right. So the clouds would deter the incoming light. So you need clear skies. That's very very important. So that is why most of our time goes in just so we take all our equipment, go to a place where it is dark, and just wait for the skies to clear. And many times the weather predictions are not accurate. Sometimes the sky clears, sometimes we just come without seeing anything. Then there was the planet Mars. So we kind of expect this kind of image of the Mars to see, right? But this is taken from a Hubble telescope, which is outside the Earth's atmosphere, and it's a big telescope in space, which is taking all these photos. But what we see is probably like this at best. Okay, so you would see some white thing, which is the polar ice caps, CO2, frozen CO2, frozen carbon dioxide, which is at the poles of Mars, and you will see probably some minor, some small details on the surface of the Mars, and at best, this is at best. So yeah, it's so the view through the telescope may not be as good as the Hubble telescope, but of course, this itself is very very exciting to see. Jupiter looks really great in a telescope. So you can see four moons of Jupiter. So they are Io, Europa, Ganymede, and Callisto. Sometimes these some of these um, some of these satellites go behind Jupiter and they will not be visible. And sometimes you can see all four of them. And this is how actually Galileo found out that Jupiter also has moons. So Galileo was actually looking at Jupiter and he saw some four stars which were just dancing around Jupiter. And then he realized that Jupiter actually has satellites and all these satellites are revolving around Jupiter. And this photo was taken with the telescope, with my telescope and my camera. So you can see the great red spot, and then you can see all these bands on the surface of Jupiter. Saturn is the most beautiful thing that you can see through a telescope. So this left side photo is with the Hubble telescope again, but from a telescope you would probably see something like this, or maybe a little bit better. So um, you can see the ring, and if you actually look closely, you can actually see this division in the ring, which is called the Cassini division. So Saturn with its ring, it looks really really awesome. It probably looks better than the photo that I have taken, but not as good as this. And then you have Uranus and Neptune, which just look like small blobs. So apart from the objects in the solar system, we can also see many other things like clusters of stars. Um, this is called M7, Messier 7. So there was this guy named Charles Messier who made I think his name is Charles Messier, but it has an R in the end. So let's just call him Messier. And he made a list of 110 objects which can be easily seen so through naked eye, through binoculars, and through small telescopes. And this catalog of objects, it has many different types of objects. So some are clusters of stars, So these are called open clusters of stars, and these are called globular clusters of stars. So this particular globular cluster, it's called Omega Centauri. It's in the constellation of Centaurus, which is very nicely seen from South India. Very difficult to see from other northern parts of the world like Europe and US. But it can be it's a very nice object. And you can see the difference between these two clusters here. All these stars are kind of far away, and they don't look like one bunch of stars, but here they are very close, and there are hundreds of thousands of stars in one globule. This is called a globular cluster. Similarly, you have nebulae. So here you can see a photograph of Orion Nebula, but when you see through a telescope, probably it would look like this. So visually it would look like this, but on a photograph you can get a much better view of the nebula. There are many different types of nebulae. So this is called an emission nebula. And there are other types of nebulae called planetary nebulae. All these photos are taken from professional telescopes, not even by me. So they may not look as beautiful, but they are really interesting. All these are dead stars. So you can see a small star in the center, which is a white dwarf star, and when the star exhausts all its fuel, it basically throws away all the material to the space, and there is no more fusion, and the star is dead. And this is how all these stars will look once they are dead. And these are called planetary nebulae. And you have galaxies. So you can take photographs of the galaxy, but when you see through your own eyes, it would probably look like this. So there are many different types of galaxies as well. There are spiral galaxies, there are irregular galaxies, there are elliptical galaxies. So many different things to see in the sky.
Kiran,
hello. Yes.
Yeah, Kiran, Kumar here. Just a quick question. Sorry to interrupt. Yeah. So two questions. How do you decide which one to look at, and how do you know where to look at it? Are there coordinates which come as the kind of a catalog kind of thing which is already there, which we can use?
Okay.
Or is it that you just go search through internet and then get individual coordinates and come back and then do it?
Okay. Okay. I understand. So there are many different books called sky map, sky charts. So so you can search for Mag 7 sky chart, and you have these things. So let me just open one of them, maybe. So you have these kind of sky charts, and here you can see all these objects, right? So you have all these numbers, NGC numbers, and so on. And then you have M numbers. M stands for Messier objects. Messier objects are usually brighter, can be easily seen with a small telescope or even a binocular. NGC objects are usually not very easy to see, and you will need a good telescope to see NGC objects. There are exceptions, like there are many brighter NGC objects in the southern hemisphere which were not catalogued by Messier, who was in the northern hemisphere. So sky charts are really interesting. So you can just take printouts of this entire I think 10 or 11 sky charts, and 20, I think. So 20 sky charts, and you can use this to find new objects. The other one is the Messier catalog. As I told you, that's the starting point. And then there is Stellarium. So Stellarium is a really wonderful software using which you can explore the sky. So this is Stellarium, and you can see uh, you can enable these things like this. This is for constellations, and you can see the constellation names. And let's say, for example, this is set for Coimbatore for today at 7:30 p.m. For example, and you can see there is a moon in the sky in Capricorn, and you can see many different things. And here. Um, Here you can actually just give me a second, please. Okay, all right. I had to adjust the brightness of my monitor. Um, so here you can actually click on this one, which will show you all the objects, all the very nice objects in the sky. So yeah, so uh, so basically the Milky Way is over here. Uh, I don't know why it is not showing the Milky Way. Let me just see. Is there some setting? Anyway, so the Milky Way, the band of the Milky Way actually passes over here. And you can see there are a lot of very nice objects in this Milky Way area. We can try to zoom in on something and see whether. Yeah, so you can see here, you can see some nebulae, you can see Catspaw Nebula, Lobster Nebula, you can see some open clusters of stars like this Ptolemy's cluster, and then you can go here, you can see there should be, um, yeah, there should be a globular cluster over here. Yeah, you can see here you can see the nebulosity around Antares, and then you can see there is this Rho Ophiuchus Nebula, and there is a beautiful globular cluster over here, which is called M4, Messier 4, like this. So you can start searching for, let's say, M1, M2, M3, M4, like that. Uh, you can do that way. And using Stellarium, you can actually zoom in and see a lot of things. And if you want to, if you have a telescope and you want to know how it would look in a telescope, you can actually set all your telescope settings here, like what kind of telescope you are using, what is the field of view, if you are using any multiplier like a Barlow lens or something, and you can see the view through the eyepiece. And if you want to photograph, you can choose your camera over here, and you can choose maybe different lenses, uh, and then you can see how the object would look in the camera field of view. So there are all these different objects available, different options available, which are very nice. Um, Yeah, so regarding finding the objects, one more thing that you can look at is its magnitude and surface brightness. So anything which is magnitude 9 or less, you can easily see through a small telescope. Anything beyond that, you will need probably a slightly bigger telescope. But over a period of time, as you get more and more experience, you would be able to see fainter and fainter objects through a small telescope itself. So yeah. Um, Another thing that I wanted to show you in this is that we can see Jupiter. So let me zoom in on Jupiter. Currently, uh, Jupiter, Saturn, Mars, all these are in the night sky. So oops, so you can see here. This is at uh, 10:30 in the night, and at 10:30 in the night you can see Jupiter, you can see Saturn, Moon, and Mars, and all these things, right? So you can see that they are almost in a straight line, right? So that's because all the planets are revolving around the sun almost in the same plane called the ecliptic plane. So I mean, sometimes you see all this news in the uh, newspapers and TV channels that the stars have aligned or the planets have aligned in a straight line, but they are always in a straight line. So don't listen to all those news. And then here you can see Jupiter. So this is the current. So at what is the time at 10:30 tonight? If you see Jupiter, this would look like this. So you would see four moons of Jupiter and the Jupiter itself. And you can see here on Jupiter, you can see the great red spot and the cloud bands of Jupiter. Right. So actually, if you look through a telescope, it will look like a cricket ball with seams on it. Right. So it's a very nice view. And similarly, you can actually zoom into Saturn. Saturn also has many different satellites. So Saturn would kind of look like this with its many satellites. You could probably see this gap, which is called the Cassini division. So yeah, this is how Saturn and Jupiter would look like if you saw through the telescope today evening. All right, we are running out of time, so let's continue with the presentation. Um, I have a lot of things to cover actually. So, how do you start photographing? So, photographing with a telescope is actually very difficult to start with. Maybe you can take a photo of the moon. So, yeah, this moon photo was taken with my own telescope. All the other photos that I showed you, they were taken with a different setup, which I will explain later. So the best way to start photographing the night sky is using a DSLR and a lens. Now, when you use a DSLR and a lens and a tripod, you have to be very careful. Um, or a mobile. I mean, nowadays you can even do the same thing with mobile. So whatever I explained here with DSLR and lens, you can also try to do with mobile. Although mobiles are very limited, but they are improving very quickly. So this was one of the first photographs that I took. On the left side, you can see the constellation of Orion. Orion is a hunter. You can see hunter's head over here. He has two arms. He has a belt over here. He has a sword, and he has two legs, one here, one here. So he is a hunter. And when I took this photo, I was very happy that yes, I photographed the stars. But if I just zoom in and see, there are many things wrong with this image. Like if you see all these stars, they are not even in focus. They are not even pinpoint. So the camera cannot autofocus to the stars. So you have to manually focus them. So if you have a DSLR, open the live view, zoom in at 10x zoom, and then you manually turn the focuser of the lens and make sure that all the stars are pinpoints. So that's very important. And then you can see here, if you see this star, there are two stars over here. And then there are two stars over here. And then there are two stars over here. So which means when I click the photo, probably the camera was shaking. And because of the shake, every star has turned into two different stars. So there are many things that you have to take care. You have to use a sturdy tripod. You have to use infinity focus by manually setting it using 10x live view, and you have to use a timer to avoid the shake. And once you do that, and once you click an image, you'll get a beautiful image like this. And this image was of Andromeda galaxy with just a tripod and a camera with no tracking device. So if I zoom in, you can see that all these stars are now just points. They are not big blobs that you see here. So all the stars are points, and you can see the Andromeda galaxy in this view as well. So this can only be done to some extent. I mean, after you do this, um, you would want to get a better view of these objects. So I also wanted better views of the object, and then I saw somebody had written on a blog that if you do a longer exposure, maybe like 1 minute or 2 minutes, then you would get really good photos. So I tried that, and what I found was that instead of getting stars, I started getting these lines. So this is again the Orion constellation. You can see these three stars in a line, right? So head of the Orion, arms of Orion, belt of Orion, two legs of Orion. But when I do when I did long exposures, all these stars they were they became lines. And why is this? This is because the Earth rotates. So because of the rotation of the Earth, all the stars are actually moving in the sky. So somehow we have to compensate for this movement of stars. If we don't compensate for the movement of stars, then we get all these streaks. But with streaks also you can do many different nice things. So these are two photos called star trail photos. So you can actually take many small shorter exposures and combine them together and make a beautiful photo like this. So the foreground here, whatever you see, this is a 22-meter gamma ray telescope which is installed in Ladakh. Um, it's in a place called Hanle. And here you see the other type of star trails, where the stars are trailing either towards left or towards right. So this is when so you get this kind of star trails when you point the camera towards the North Pole, and you get this kind of photograph when you point the camera towards east or west. Okay. So I'll just quickly show you a demo of how to create this kind of images. So you need to take multiple images. So you can see my first image was this, second image, third image, fourth image, fifth image. And you can see in all these, the stars are moving. And then I use a software called Star Trails. So it's called Star Trails. You can just search for Star Trails software and you'll get it. And then you open all these images and then create Star Trails. So yes, okay. And you can see that it is adding all those images and creating a final image. So one thing that you should note is that there is this beautiful star over here, which is not at all trailing or trailing very, very less. And this particular star is the North Pole Star or Polaris. And this was the one that was used by all the sailors to find the direction in the sky. So here also you can see, I can go to north and you can see the pole star over here. So and if you see the altitude of the pole star, this is around 11 degrees. So 11 degrees is the latitude of Coimbatore. So for the South Indians, the star will be very low in the sky, and it is kind of hard to actually find. But if you go to some Western countries where the latitude is very high, you have to look high up in the sky, and it is very prominently visible in the night sky. So here you have Star Trail's image. Here I just combined 21 images, but this picture in the presentation, this was done with more than 60 images. Okay, so star trails are beautiful. If you don't want any trailing, then you need to have some kind of a tracking mechanism. So you need to have a motor to track your camera, or you need to manually track the camera with the stars. So easy setup that can be done is using something called as a barn door tracker. So you take two pieces of wood, put a hinge between them, and you take a threaded rod and connect a, motor, stepper motor to it, and turn this stepper motor so that the threaded rod just moves the two planks of wood apart, right? So here now this will make this camera turn from east to west. So one thing that has to be done is this has to be aligned to the North Pole. These hinges have to be aligned to the North Pole so that when you turn this motor, this camera is actually turning from east to west, because all the stars are moving from east to west. So this camera also has to move from east to west. So this particular setup was constructed by my friend Arun Venkataswamy. He's from Chennai. He has his own blog called wondroussky.blogspot.com. On his website, you can see the design. You can get the code to run this stepper motor, and you can also see some of the images that he has taken with this barn door tracker. So this is one of the images of Orion Nebula, and you can see this is a long exposure, but all these stars are still pinpoint and they have not trailed. Okay. Yeah, so this is how barn door tracker works. There are also similar commercial products available. So one is called a Vixen Polari. There is also another one by a company called iOptron, and this is called an Astro Track. So there are many different solutions available, but they also work in the same way. Basically, you have to align the axis of rotation to the North Pole, and you track the objects, track the camera from east to west. And the speed of this should be one rotation per day, right? So the final goal is that all the stars are rotating at one rotation per day. So our camera should also go at the same speed. So the speed has to be adjusted. Okay, so once you start doing that, you'll start getting better photos like this. But if you want to go one step further, what you need to do is you need to start stacking the images. So what is the meaning of stacking? So what is happening in the sky is that, let's say you have some object in the sky, which is like this, but the camera itself produces a lot of noise. And finally, what we are getting out of the camera is an image which is very, very noisy. Now, this noise is actually random. I think you all are from engineering background, so you know what random noise is probably. So the position where this noise is generating, it's different in different photographs. So if you take 100 photographs and then try to average them together, then you will start reducing the noise, and that's what we call as stacking. So if you have 32 images, from this you will get something like this, where the noise is reduced a little bit. With more and more images, the noise gets reduced a lot. But of course, if we take 1024 images, the noise is virtually not present. But to take 1024 images, you would have to take the photo of some object for a year or more than that, so which is not possible. And there is a software called Deep Sky Stacker, which will do all this automatically. So you need not uh, basically write any program to do this stacking. It can be done by different software. So to just give you an example, one frame or one image would look like this. And once you stack many images, you will start seeing the object. So this is one object. Sorry, this is one image where this object was not even properly seen. The color was not prominent. The tail of this comet was not seen. But after stacking multiple images, you can see the color, and then you can also see the tail of this comet. So currently the setup I have is something like this. So I have a small mount for tracking. And then I have a camera on top of that. And if I want to photograph planets, I use a Schmidt-Cassegrain telescope like this with the camera over here. And for deep sky objects, I use a different setup. So there is a different, this is a different mount. This can take more weight. The tripod and all were constructed by us. So basically it's all homemade. And then you have a telescope to take the photos. Next. And then, yeah, let's not. So I'll try to show you some more photos and try to explain uh, what was done for those photos. Maybe let's start with this one. So this is the photo of Andromeda uh, galaxy. So you can see there are actually three galaxies in this image. So all these were taken with either a lens or a telescope and with tracking, right? So on a tracking mount. So you can see three galaxies here. There is one big galaxy over here with all these spiral arms, and you have another small galaxy here, another galaxy here, and all these three galaxies can be seen with a small telescope, and this big galaxy can be seen with naked eye as well. So if you actually go here and search for Andromeda galaxy, so the Andromeda galaxy is over here, and you can actually, with naked eye, you can actually see something like this. And if you have a binocular or but you have to be in a dark location. If you have a binocular or a telescope, you can actually see better views. And with the camera, you can take very nice photos like this. This is Milky Way over the Himalayan mountains. So this was taken with an ordinary DSLR camera with a wide angle lens without any telescope. Another photo of the Milky Way with just a wide angle camera and wide angle lens and the camera, no telescope. This was with a 50 lens. This is actually mosaic. So there were three images which were stitched together to make this panorama of the Milky Way. And here, actually, all these individual photos before stitching, they were actually stacks of multiple photos. So I took multiple photos of the same area of the sky, stacked them together, combined them together, and then I made a mosaic of that, and looks like this. So it's already, so the time is up, but I have to still cover many things. Can I continue, or how do we do this? Are there any, yeah, who was it? Sai or somebody? Can you, Rakshit?
Yeah, Continue, sir.
Okay, so maybe I'll take another 30 minutes more. Is that okay?
Yeah, okay, sir.
Okay, all right. Thank you. Um, so this photo is of Horsehead Nebula in Orion constellation, and this was taken with a telescope that I showed earlier. So it was taken with this telescope. This is Orion Nebula. Um, Another photo of Orion Nebula again. This cluster is called the Pleiades cluster. So I will show you how this picture was made. So once I took many photos and then stacked them together, it was actually looking like this. Actually, it looks like this. So you can see all these stars over here, but no nebulosity can be seen. So we can try to automatically stretch it and see how it looks like. So you can see that there was a lot of background light. So that background light can be seen here. And it is actually a gradient. So here it is brighter and on the sides it is not so bright. And also another thing you can see is that when I did the stacking, um, basically I took multiple photos, right? So when I aligned them, they were not aligned properly. So you can see that there is some artifact below here and also to the left. So first I need to do the cropping. So let me just take out all these edges, which we don't need. The software that I'm using here, it's called PixInsight. Uh, it's a paid software. It's not a free software, but it's a really good software for astrophotography and for basically image processing. So what I want to do next is remove this background noise, a background gradient, and we have a tool for that. So what this does is you can see this background, right? So this background was extracted from this image and it will be removed from that image. So then after we remove the gradient, the this looks much more beautiful. And then so still this image is not bright enough. So we have to make it bright. So you can see this is called a histogram. You can see that um, you can see how many pixels have what kind of brightness, right? So the x-axis is the brightness and how many pixels have this particular brightness. And you can see a peak over here, which means all the pixels are dark and we have to make it brighter. So we are making it brighter. So now you can see most of the pixels are in this particular region. So they are getting brighter. And once we do this, we can do many different things. But what I will do just is just try to increase the contrast, try to increase the colors a little bit. and there is this kind of greenish tinge which I want to remove. I don't want it to look green. And you have, yeah, you have this image. So you can see a lot of details in this image. So you can see a lot of, so basically this star cluster has many stars and a lot of dust around the stars. So the light from the stars is reflected by the dust, and that's what you see as this blue color. And you can see stars of different colors. You have kind of orange color stars, blue color stars, white stars, and so on. So this is a very, very nice star cluster. So um, to get any, yeah, I mean, you definitely need to do a lot of processing to make the star clusters or nebulae look beautiful. Um, because the camera is not really camera. I mean, whenever you take any photo, camera internally does a lot of processing, but the camera is not designed to process the astronomical images. So you have to do some astronomical. You have to do some image processing to um, get good photographs of the of astronomical images. But one thing that we have to remember is we are not adding anything. We are not adding artificial stars to this, or we are not adding any colors. We are just enhancing the colors that are already there in the image, and that is really required uh, to make it look pleasant. So yeah, so that's how we do image processing of these objects. So the same thing can be done with Photoshop as well. Many of these things can also be done with open source softwares, free softwares like GIMP. This was a photo of solar eclipse in 2017. This is Omega Centauri, the globular cluster that I showed earlier already. These are two galaxies called M81 and M82. These are three galaxies in the constellation of Leo, called Leo triplet. And all these objects that I am showing you, they can be easily seen uh, with good binoculars or telescopes. This is called Centaurus A galaxy. This was another star trails wherein there were sheep which were just sleeping here, and the stars were trailing above. This is the east-west, sorry, the east star trails. So here you can see that this is towards north. So all these stars are trailing towards north, and all these stars are trailing towards south. This was GSLV launch. So if you guys, I mean, you can check when ISRO is launching its rockets, and you can actually go to Pulicat Lake and see the rocket launch, and it looks really beautiful. This is the full moon. All these colors are after increasing the saturation. This was during a partial lunar eclipse. So you can see the shadow of the Earth falling on the moon and covering the moon. This was during the total eclipse. This is called a penumbral lunar eclipse. Basically, you can see the complete moon, but this part is kind of less bright than the other part, and that's the penumbral shadow, which is not. So the difference is this is the umbral shadow, which is covering the moon, and moon actually starts disappearing in the night sky. But here you can only see some change in brightness, and the moon is still visible. That's called the penumbral shadow falling on the moon. This is Jupiter, and this photo was actually taken with, I told you that it's with a different telescope, and that's this telescope. It's called the Schmidt-Cassegrain telescope. This was Venus. So the Venus was passing in front of the sun on 6th of June 2012, and this photo was taken during that time. The next time this event will occur is in next century. So we will probably none of us will be able to see it again. Yeah, this photo was taken during meteor shower. So if you want to see meteor showers, Geminide meteor showers that occur in December, that's the best one to see. So you can actually just point the telescope, point your camera with a very wide angle lens to the sky and just take continuous shots. And in some of those shots, you will have meteors, and you can combine all those photos together and make one photo like this. So if you want to see meteor showers, you don't really need a telescope or binoculars. Actually, you can't see meteor showers with telescope because in telescope, we are only looking at a very small area of the sky. But if you want to see meteor showers, you just sit down on the ground, sleep on the ground, and just keep looking at the sky. And during Geminide meteor showers, which occur in December, you will see hundreds of meteors in one night. This is another photo of the Milky Way, again taken with a wide angle lens. So this was taken with, I think this was taken with 11 mm lens with DSLR camera. This is the photo of Venus and Jupiter. So the Venus, planet Venus is here and Jupiter is here, and you can see the four moons of Jupiter. This was taken with a telescope of 1000 millimeter focal length. This is called Elephant's Trunks Nebula. These are photographic nebulae. These are very difficult to see through our eyes, even through a telescope. But on photographs, you can get really good photos of this. These are called heart and soul nebulae. So this looks like heart. And I don't know how this looks like a soul, but these are called heart and soul nebulae. So on a Valentine's Day, this is probably a very good gift. You can photograph this and give it to your loved one. Eta Carina Nebula. This is called Lagoon and Trifid Nebulae. This is the Pleiades star cluster that I showed earlier with another nebula called California Nebula. It seems the shape looks like the state of California of US. Probably in India, we can call it as Kerala Nebula or something if you think it looks like the state of Kerala. Then we have the Orion Nebula, Horsehead Nebula, and Flame Nebula. This was during a total lunar eclipse. This is an open cluster of stars with the planetary nebula in that open cluster. So there are hundreds of these stars, and one of the stars has died and it has turned into a planetary nebula. Again, some more star traits. This is another photo of the full moon. Another photo of Orion Nebula. This is Milky Way, and there was a guest, which was a comet. Another Milky Way photo. This was Milky Way along with some lightning. This is a very nice place, Hanle, in the Ladakh. And in Hanle, the professional astronomers, they have TIFR and IAA, they have set up gamma ray telescopes. So these are 2, 3, 4, 5, 6, 7, 8. So there are many gamma ray telescopes. And yeah, there was a meteor also in that image. You can see the Pleiades star cluster here. And you can see that the stars are actually trailing. So all these are not points, but they're small trails. So this was taken with a tripod and a camera, so you can see some trailing of the stars. Yeah, this is just a selfie with the Milky Way. This photo is called Markarian chain of galaxies. So there are so in the constellation of Virgo, there are many galaxies that can be seen in one field of view. Let's fast forward the time a little bit. Okay, maybe we have to go forward by a few months. Yeah. So there is this constellation of Virgo, and here, if you enable these things, so here you can see a lot of galaxies. So there is Berenices and there is Virgo, and in this region, there are a lot of different galaxies. And there is one chain of galaxies which is over here, which is this Markarian chain of galaxies. So do you see all these galaxies here? And this is the photo of that same region. I think there is a, the orientation is slightly wrong, but it's the same region. You can see these eyes, and the eyes are over here, and you have all these other galaxies. So you can see some spiral galaxies over here. These are also spiral galaxies. All these are elliptical galaxies. And this is a really, really wonderful field of view, wherein if you just point the telescope in any direction, in any place in this region, and you will see many different galaxies. This was also during the Venus transit. So the Venus was passing in front of the sun. So this photo was taken with the telescope and a filter in front of the telescope. Because you should never aim the telescope at the sun. You will just burn your telescope, maybe even burn your eyes. So never do that. But with a good filter, you can actually take the photo of the sun, and you can actually see a lot of sunspots. So sunspots are kind of relatively relatively low temperature areas on the sun. So this is something that you can do as well. So yeah, so all these so basically, even with low budget, you can do many things. You can construct a barn door tracker. You can even take the photos with just tripod and camera, and even with the mobile, you can just do a lot of things. But to know the sky, you can use softwares like Stellarium. There are also many different apps called Sky Map. The Stellarium also is available as an app. And also you have Sky, Skeye, which was developed by an Indian, Harshad, who is a member of our Bangalore Astronomical Society group, which is a fantastic software. So there are many, many different apps like that. You can make use of them. And then one last thing that I wanted to mention about is regarding light pollution. So you have to, in India, there is, so if you see the view from a satellite during the night, it looks like this. So you have all these different cities and towns which have a lot of lights, and you need to find somewhere where there are no lights and go to that place to get a very good view of the sky. So there is this area, which is Ladakh in the Himalayas. So Himachal Pradesh, Ladakh, which is kind of okay. Ladakh is really, really good. It has one of the best skies in the world. Himachal Pradesh is also kind of okay. In South India, we have the Western Ghats, where there is still some hope. and some areas in Andhra which are okay. There is some area in Chhattisgarh and Orissa, but they are not very safe um, because of Naxals and other issues. There is some place in Rajasthan, in the deserts of Rajasthan, which are also good. So going to these places would be ideal, but even going to any village which is 100 kilometers away from big cities and where there are no local lights, that should be enough. So most of these photos that I showed you, they were taken around 100 kilometers away from Bangalore, from a small village. Yeah. So there are many resources available. So yeah, the star charts, I already showed you the star charts, and also stellarium, which is really nice. Or you could even go to our website, which is bas.org.in, and here there is a you can click on this download logbooks, and you can see logbooks which were created by one of our members, Akash Simha, and he has made a really um, it's a nice project. So just give me a minute, it will get downloaded. You can take printout of this book, and you can log all your observations. So this book is for logging Messier objects. So for example, this is the first object in the Messier catalog called Crab Nebula. It is supposed to look like this. So you can, if you are trying to observe this, then you can use this format and log the date, time, equipment, magnification observed from description, your own description of the object, whether it was bright, whether it was not so bright, whether you saw it through, whether you could easily see it or you had to struggle, and what was the shape, did you see any of these details, and so on. And also, if you want to do a sketch, you can do a sketch over here. And this is a very nice thing to do. And similarly, there is a logbook for bright galaxies, some more galaxies, globular clusters, and so on. So this is a very nice collection of books that you could print and use to make your own observation logs. And very nice thing is that whether it shows whether it can be seen through binoculars, through telescope, and so on. And you can see all the description for everything over here. So naked eye, through telescope, through binoculars, etc. So let's stop at this and see if there are any questions. How to take a picture from a telescope? Okay, I did not cover this. So the setup would kind of look like this. So you have your camera, which has an adapter. It's called a T-ring adapter, and you buy the T-ring adapter and you directly put the camera where you put the eyepiece. So it would kind of look like this. So in case of reflector also, it's the same thing. So you have the camera and you have the T-ring, and there is a T-ring adapter, and this just goes where the eyepiece would go, and you would use the focuser to focus and to bring it to to make all the stars appear like dots. and you would just photograph it. We need to capture during clear sky, right? Yes. Um, how to capture pictures by remote telescope? I have never photographed anything through remote telescopes, uh, but there are some remote telescopes where you can buy the telescope time. So sometimes you can just pay them to take photos for you, or and you can just say I want to photograph this particular object. They will take photographs of that and then send you, and you can process them. But I have never really tried taking photos with a remote telescope. How to arrange the eyepiece lenses in a reflection telescope? How to arrange eyepiece lenses? I mean, eyepiece, you just buy an eyepiece and then put that in the telescope. That's all. It's difficult to make an eyepiece. So let me just try to show you that. Yeah, here you can see the eyepiece, right? So there is a focuser. This focuser has a tube, and then you just put the eyepiece in that tube, and that's it. Probably I don't understand your question, so maybe you can unmute yourself and ask. Star Max 7 sky map, the chart coordinates are always constant. Yes, they are always constant, at least for the next 100 years. So maybe over thousands of years, it may change, but at least for the next hundreds of years, it will be this. It will be constant. While making your own telescope, how do you manage to get rid of chromatic aberration of lenses? Yeah, I mean, when we make our own telescopes, usually we make reflective telescopes. That means we use mirrors, and mirrors usually don't have chromatic aberration. So, but they will have spherical aberrations. You have to make that concave surface into a parabola, but you will not have chromatic aberration. For the lenses, if you're making lenses, um, you have to use a doublet, or you have to make a doublet or a triplet to get rid of chromatic aberration. So you have to have one convex lens and one concave lens, put them together to reduce the chromatic aberration. So that is why in the lenses, like in photographic lenses, you have many different elements. So all these 200 mm, 300 cameras, they are very heavy because they have many glass elements. Sometimes they have from 6 to up to 13, 14 elements of glass to reduce the chromatic aberration, reduce the different artifacts. So, yeah. Sir, which telescope to buy and what specs do we need to consider before buying? As there are many options and it's confusing. So I would recommend something which has at least 6 inches diameter. So um, So this kind of Dobsonian telescopes are usually cheaper than other kinds of telescopes. And here you can see the mirror, right? So the mirror diameter should be at least 6 inch. Um, Anything less than 6 inch is not very useful. There is a 5 inch telescope which is cheaper, which is called Celestron Astromaster 130. That is okay to start with, but probably in a year or two you will grow beyond that, and you will not be. You will probably need a bigger telescope. So at least 6 inch is good. 8 inch diameter would be much better. So the focal length and all are secondary. The size of this primary mirror is what matters the most. But for photography, it's a totally different thing. So for photography, you can just do with your camera and lens. And I use a 200 lens many of these photos that I showed you were taken with a 200 lens. So you don't really need a you don't really need a telescope to do photography. But for visual, anything with at least a 6-inch diameter uh, um, mirror would be good. Let's see. Are there any other questions? What is the future of astrophotography? Any advancement? Yes. So 15 years ago, we did not even have live view. So many people 15 years ago were still using um, film cameras. So 15 years ago, people started using digital cameras, and then everything got changed, right? And then 10 years ago, we started getting live view. So with live view, we could just zoom in to the image and then focus to the stars with very high precision, so that we could get really, really sharp images. And then at that time, there were new products coming up, even with the mount, really good mount, which can track very well without any errors. And recently we have, and then um, till probably 5 years ago, you used to get, I mean, there are some dedicated astro cameras, and these were using CCD sensors and a cooling unit to cool the temperature so that you don't get much noise. So instead of CCD sensors, now there are new astro cameras coming up with CMOS sensors. So these CMOS sensors are much cheaper. So at the price of uh, DSLR camera, you can actually get a dedicated astro camera. And instead of using these color cameras, we can use mono cameras, and with some filters in front of them, and those actually produce better pictures. So in terms of camera technology, the camera technology has improved a lot, so we can easily get much better photos nowadays. And then apart from the camera technology, the softwares have improved a lot. Like for example, this Pix Insight, I think this, yeah, probably 10 or 12 years ago, this software was started, and over a period of these 12 years, it has improved quite a lot. There are a lot of different features. Like you can see, like in just 3 or 4 steps from from a really bad image, we made a really good image, right? So this was the initial image, and with just one, two, three steps, we were able to come up with a really nice image. So in software, there are a lot of things going on. And there are a lot of other equipment, like you get robotic focusers, so you need not focus with hand. There are softwares which take photo, see whether stars are in focus, and they have all these motors which can autofocus the things. So there are many many different things there are new products every day that are advancing, that are helping us advance the astrophotography. Sir, there are two types of telescopes, radio and optical. Which one is better? There are many different types of telescopes for different applications. So it depends on you what you are more interested in. Radio telescopes can be used to. Um, I mean, I'm talking from amateur perspective, right? Amateur astronomer perspective, as a hobby. What you want to do. So as a hobby, I prefer optical telescope. From professional perspective, different telescopes have different applications. So you have radio telescopes, you have gamma ray telescopes, some of the pictures that I showed you earlier, and then you also have X-ray telescope, like Chandra X-ray telescope, which is in space. There are um, infrared telescopes, there are ultraviolet telescopes, there are many different telescopes, and each have their own use. So I can't say which one is better, but from amateur perspective, uh, optical telescopes would give you visual, I mean, much better visual views than radio telescopes. Okay, so I hope I was able to give you an overview of astrophotography as well as astronomy and what you can do with a small telescope. So we have a group called Bangalore Astronomical Society. So we have yeah, I can probably show you this. So yeah, I can share the link with Sai or someone. This in this group we discuss a lot about all the different astronomy topics. It's completely free and non-profit. We are not trying to make any money out of it. We also have our own YouTube channel called Bangalore Astronomical Society. So every 2 weeks we conduct online sessions, and these online sessions are conducted by our members. And you can see we have many different videos on many different topics. So you can search for our channel. So you have live stream of planets. You have a guide to buy a telescope. What are the different types of telescopes? There are some things on deep sky astrophotography, and then planetary astrophotography, and then series of sessions on visual observation, like from using just naked eyes to see how to use a very big telescope and how to see objects. So we have about 8 hours, 7 8 hours of material only on that. So we have a lot of things here which you can see. And again, I mean, you can see the number of views. We are not trying to make any money out of this. This is all non-profit. Sir, will you upload? So I'm not recording the video. I think somebody else is recording the video. So if you can provide me that video recording, I can upload it on our BA's channel itself, and
Yeah,
you can see.
we'll provide you, Kiran.
Okay, all right, great.
So, shall we wait 2 more minutes for any questions?
Yeah, sure.
Okay. Participants, you can ask your questions in the chat box or you can unmute yourself.
Yeah, please unmute yourself and ask. That would be easier.
Yeah.
Okay, so please provide any feedback that you have or any other things that you would want to discuss about, and probably to Sai or somebody, and they can send it to me. Also, you can join our Telegram group. It's a nice. It just has about 200 members, and if there are any astro events or even space events like rocket launches and all, you get notified in this. And also, there are a lot of interesting discussions about amateur astronomy. So yeah, you can join this.
Okay.
All right then. Thank you very
So,
much.
so okay, let's conclude the session. So, I, on behalf of SEDS KCT, want to thank and extend my gratitude to the speaker, Mr. Keerthi Kiran, for joining us on Space Talk series. Feedback link will be sent in the chat box. Kindly fill it to receive your certificates. Thank you.
Okay, thank you. Bye.
Thank you, Mr. Kiran.